Nutrition Step 1. We'll take inventory, discuss some macromolecules, carbohydrates, proteins, and lipids, and micromolecules such as vitamins, minerals, and other molecules. And we'll get an overview of the understanding of humanity's dietary change, how things have been transitioning, and your own dietary change. Welcome to PaleoLegacy.com. This is Mark Lorenzato, MD. You personally can take inventory by photographing the food you eat. You can make a list, handwritten list. What you're eating determines a great amount of your health, your well-being, and how you deal with illness. What you look like and feel like by your subjective measures is equally as important as anything we measure. Are you flexible? Do you have good muscle tone? Your fat distribution? Be honest. We're starting out new here. We want to have your understanding. Your cultural liabilities, when we talk about inventory, are the greatest thing to look at. Were you born in a culture where food is unhealthy? In many cuisines, there's an overuse of starch, rice, potatoes, overuse of fat, particularly fat that is from sources without fat-soluble antioxidants and vitamins. We'll go into this. Celebratory foods. How often do we have things that are sugar-laden or with dyes and sugar and refined oils in the name of celebration? Very unhealthy thought. Alcohol can be in this category as well, and we can look at that at some point. Workaholics, putting your work above your food and your health can be catastrophic. We all need to change our culture a little at a time. Certainly compromise is part of the picture and we accept it, but we need to see it for what it is. Let's move on. Carbohydrates encompass a large group of molecules. Particularly sugars are the building block for most carbohydrates. They themselves are carbohydrates and they're the building blocks for bigger ones. So there's an infinite number of ways sugars can be combined, and sugars also become part of molecules when they bind to proteins and lipids, fats, and such like that. Some sugars are important to know particularly. Glucose is a common currency of our energy. We use glucose in our bloodstream to transfer energy, but more importantly, perhaps, inside of the cell, glucose is broken down and provides energy. Starch in many foods is taken away from the whole food and separated. Starch is glucose hooked to glucose hooked to glucose tens of thousands of times, hundreds of thousands of times, molecule after molecule. When we eat starch, we typically flood our systems with glucose. Sucrose is table sugar. It is glucose and fructose. Fructose and glucose are about the same caloric and same amount of energy, and fructose is easily converted to glucose. Most sugar calories are absorbed rapidly in the small intestine. Glucose, fructose, and galactose are absorbed immediately. Other sugars don't contribute as much. Sugar alcohols may be absorbed in the large intestine and not immediately in the small intestine, so they'll cause fermentation and bloating. They also do not cause tooth decay, so there can be some benefit for sugar alcohols. And fiber is the term used for carbohydrates that are not absorbed in the small intestine or mouth or the membranes and go to the colon, where they're either fermented by bacteria or they're passed through. Proteins, huge group of important molecules that are famous for their enzymatic benefit. They can make chemical reactions happen with much less energy involved. The enzyme systems, the protein management systems in our body are only one part of what proteins are about. Proteins are made of amino acids, and the proteins in things like legumes and cereals and vegetables are different from those that are made in muscle fiber and animal organs. So proteins are different. Amino acids are mostly derived, the amino acids are mostly delivered to cells in the form of albumin. This is a serum protein that carries a lot of our protein throughout our bloodstream. Some amino acids are converted to glucose for fuel. So a person does not really have to eat any sugar. They can eat protein and survive on protein and fats without sugar if they had to. Nonsense, it's always an imbalance. Serum albumin is the most abundant protein in the bloodstream and transports some fat-soluble molecules, such as steroids, some of them, and they also involve transport thyroid hormones as well as other functions. So when a liver is not functioning well enough to make ample protein, we also see problems with our hormonal system and regulation. And the liver is the central balancing area for managing our energy needs, where glucose is metabolized and fats are made and proteins are made and broken down. Mostly the liver. Lipids are the fats. Anything that is soluble in oil you can think of as a lipid. So fat-soluble molecules don't mix with water. Therefore, the lipoproteins, LDL and HDL and others, the apolipoproteins, are managing the molecules, the fat distribution throughout our system. Fats are composed of fatty acids and other components, and saturated fats are fatty acid derived fats that are solid, more or less, at room temperature. These will include things like cheeses and the fat that you cut off meat. De novo fatty acids are also saturated. Those are the ones that you make in your liver from glucose, from sugars, and from starch. Monounsaturated fatty acids, or MUFAs, are found in olive oil, canola oil, and some other oils, nuts and such. And PUFAs, polyunsaturated, are predominantly in vegetable oils. The steroids, including cholesterol, is a lipid, and there are many other molecules that are lipids. Vitamin D is a secosteroid, a similar molecule. Fat-soluble vitamins include A, D, E, and K. These are very critical in the sense that in the transition of humanity, we probably had more fat-soluble vitamins in our systems because we derived more of our diet from game meat, most likely. This suggests that we did not have de novo or new fatty acid production as much in our liver. Therefore, we would get the whole cell, the whole contents, as they concentrated up the food chain of these valuable fat-soluble vitamins. Major component of membranes, fats are major component of membranes, particularly the central nervous system. And as I mentioned, they're transported mostly in lipoproteins. Micromolecules. Of the vitamins, some of them are fat-soluble. They are more going to be bound, some to albumin and some to lipoproteins. They incorporate into membranes. The fat-soluble vitamins mentioned are very important. D, A, E, and K. K2 is more fat-soluble than K1 for certain reasons. Water-soluble vitamins, the B vitamins are mostly, also vitamin C, and these are equally as critical. They are brought into our system daily, whereas the fat-soluble vitamins tend to stay in our system much longer. So we can build up a supply and miss days of a fat-soluble vitamin and never get depleted. It's just released from our fat. But if we miss days of eating vegetables and fruits, we'll deplete in our B vitamins, water-soluble vitamins. The essential fatty acids include DHA and EPA. Also, the conjugated linoleic acids look like they're essential in the sense that people given them tend to have lower rates of cancer. So therefore, we would think that they create a benefit in our system, maybe in terms of DNA repair or many of the multitude of biochemical pathways. Amino acids derived, particularly those found in fats, L-carnitine, L-carnosine, creatine, choline, betaine, anserine, many molecules that are amino acid derived molecules that are micromolecules that are important to us. Metabolic intermediates, there's a vast number of metabolic intermediates, things that within any pathway, biochemical pathway, certain molecules then can enter that pathway from various other pathways. These intermediates are very powerful in terms of mitigating or transitioning physiological states. Oxaloacetate is an example of this. It may be used to promote a sense of fasting by the organism. Minerals and electrolytes, some to bring to mind, phosphates that are inorganic have been part of our diet only recently. Before that, we would get the organic form, phytic acid, from many foods, and other forms of phosphate that we would get bound to proteins and such, but the inorganic ones are overabundant. Sodium is overabundant. Zinc is frequently lost in the state of dehydration and needs to be replenished in dehydration. This may be why we think zinc is beneficial in viral infections, because we also get dehydrated at that time. And there's a multitude of trace minerals that are also, we're in an ecosystem with needing our food ecosystem. As we move up the food chain, some molecules are concentrated. And therefore, there may have been a balance of eating game meat that provided a higher concentration of some molecules that we otherwise wouldn't get. L-carnitine is an example. Industrial sources of phosphate I mentioned is very problematic, particularly individuals with any renal failure, kidney failure. Humanity's change in diet is marked by several things. One is a decrease in game meat with an increase in meat that has been fed soy and corn and limited cereals. With this, there's been a decrease in some essential fatty acids, changes in the amount of vitamin D we get, and other fat-soluble vitamins, amongst other things. There's also been problems of having insecticides and hormones incorporated in our meat supply. There's also been a movement towards cereals, and the balance of sodium and calcium and phosphate in cereals is very much different than the balance of these electrolytes that we'll find in game meat and in vegetables and nuts and fruits. Starch and glucose in overabundance is by far the greatest problem that humanity has created for us in terms of humanity's health, quite a bit, because when we eat starch, it turns into glucose, which then creates de novo fatty acids, which are very weak in the fat-soluble antioxidants and vitamins. They're transported in lipoproteins and albumins and create a deficiency of critical vitamins and fat-soluble antioxidants in our system. It's your own dietary change. It's very reasonable to look at each category of food type and try to understand what percentage of energy, of calories you're getting from food. We can do this now using Wikipedia or other sources to understand the content of our food. Whether you're getting too much phosphates, too much nitrates, too much glucose, too much cornstarch, starch, and such is very important. The sources of your oil that you ingest is critical. Extra virgin olive oil tends to be more beneficial in many ways, but its browning temperature is limited, so it cannot be used in frying very much. Frying in general is problematic. It can be used to some degree. If there are trans fats in your diet, this can be very bad. Also, the palmitic acid and myristic 16 and 18 carbon fatty acids that are frequently replacing the trans fats can be problematic as well. As I mentioned, the conjugated linoleic acids are not something that we can take extra of particularly, but when they were in our food supply, they probably gave us a benefit. Weight loss should not be an issue. As we define a healthy diet, we abide by that diet and things will move forward. So when we think about dietary change, it's not to accomplish a goal other than eating in a healthy way. In conclusion, healthy nutritional balance has been determined by hundreds of thousands and hundreds of millions of years of food ecology, the balance of the kinds of foods humans ate with their biochemical pathways, which initially was defined, it is defined by their DNA, but also by their surroundings, the proteins that are manifest. Molecular domain can be divided into macromolecules, carbohydrates, proteins, and lipids. Lipids are another term for fats or molecules that are soluble in oil. And micromolecules, vitamins, minerals, the essential fatty acids, and such like this, the essential amino acid derived molecules in meat that we make many of them ourselves. How do you fit in? We're all born in this continuum of a changing food ecology, and with that, we've become very lopsided, having too much starch, too much refined oils, excess sodium and inorganic phosphates. These things we need to change, not just for ourselves, but for our neighbors, our children, by changing society. Besides being out of balance with macromolecules, in your paleo legacy, you probably lack these micronutrients that we would have from a very diverse diet. Our diet's gotten much less diverse, and it's quite possible that some of even the mineral content we're getting from the soil is relatively depleted. So we need diverse food. We need to do our best to decentralize some of the agriculture, or at least to make sure that we're getting our full complement of the molecules we would have gotten before agriculture and industrial agriculture.